Hi, this is Jay, student number 2301061, video demonstration. All the steering behaviors have a desired force, and then we create the desired force depending on what behavior we're doing, and then it finds a rotational force to then push the ship into that direction. Seek just finds a target position, gets the distance between the two, and then pushes it towards it. Flee, the radius on the outside dampens, so the closer you are to the ship, it moves away quicker. It just moves in the complete opposite direction of the player ship by setting it as a target, and then times in the desired force by -1. You can see it slows as it gets to the outside of the radius. Pursuit has a prediction time, moves towards just in front of where the player is. Evade predicts where the player will be by predicting a vector a couple seconds in front of where its current facing direction is and moves away from that point. Arrive, the yellow radius is a slowing radius. Once the target point is within that, it will start to lerp the weight down beyond that point. This is Wander. There is a circle projected 2 units in front of the ship. It picks a random unit on that circle and sets that as the current target position, and then keeps randomizing where that point is. Collision avoidance. Each of the feelers, once it's within a feeler, it will then try to get it away from that feeler. Works with both the players and the walls. Group movement. The alignment is the force straight down the middle of the ship. The cohesion is the purple force towards the center, and the separation force is the blue forces out of the center. I've altered the weightings of this one so that it looks more realistic with how the group should move. Dijkstra pathfinding. You can see each of the squares being checked. The green is the current ones in the open list, the dark green are the ones in the closed list. This is when it is allowing diagonals and allowing cutting corners. It finds its position by the iterative loop. I turn the max speed up because it helps show more iterations of it. It expands equally around each side. I've just ticked off allow diagonals, so it should now, after this iteration, not allow for diagonal movement, which is done by just doing an if check on the direction of neighbours. If it's an orthogonal direction, then it'll be divisible by 2. So anything that's not divisible by 2, you just continue over that loop. This is Manhattan A*. Tends to move in a non-diagonal approach. All of the checked squares tend to be in the direction of where it is. Manhattan is the one on the submitted project that has been left there. This is Euclidean heuristic. Again, checks mostly in the general direction of where the seeked point is. Obviously down the diagonal distance, not just the up and down distance like Manhattan did. This is octile heuristic, taking the 8th of the shortest distance. And finally Chebyshev, which just uses the smallest distance of the two, either horizontal or vertical, as its heuristic. JPS was attempted, but it wasn't implemented fully. This is the first one where it doesn't check whether it is a jump point or not, but it shows that it's checking along each path, and it shows that it steps and then continues along each of those paths. Used a for loop of just checking on each neighbour, and then it would do all of up, and then it would do all of right, and it would do all of down, and then it would do all of left, and then it would move to the next point. I did have a check function, but it was very aggressive in how it assigned its neighbours. It would always pick anything that had a neighbour that was non-walkable, would say that that was a jump point, and it resulted in a lot of jump points being made in the check. However, with the check, it would do one of them correctly, like here, where it has all of the jump points found, and it picks the ones that would be correctly added as jump points. However, when it reaches its target, it just stops working. I don't know how to fix this. It keeps setting the end point to its own start point, as here you can see it empties both of the lists, but keeps setting the end point back to this current start point, and I don't know how to fix that, so I didn't fully implement JPS, but I did mostly implement JPS. The fuzzy state machine. There were several behaviours that I added into this over the basic just seek for a health pack, based on the health ratio. I added a seek for the ammo pack based on ammo ratio. I calculated the ammo ratio based on max ammo being 10 and what the current ammo is. I had it so that both players communicate, so that if one of the players is seeking a pickup, then the other player will not go and seek the pickup as they are attached to each other. Then if you pick up one, the other one will just be left in the middle of nowhere. They attack an enemy if they become close. There is a wander behaviour always in the background, so it will always slightly wander on a weight of 0.05. The seek then acts as a higher weight, so then it will mostly seek towards the health object. You can see as they attack, both are attacking. The health pickup was picked up as it started seeking that whilst it was attacking. They both arrive just in front of where the ship is, just like the base script did. They also flee if they have less than 3 health or less than 3 ammo, as the enemy ships have 3 health, so would require 3 ammo, or they do 3 shots back to the player. So they evade it based on that, and then if they are seeking a health pickup, evade the player and seek the health pickup at the same time. I also have radars. So once one player starts to get attacked, if the other player is within a certain range of it, it will start to generally move towards the direction of that player. I will show that in a separate video, as the first player ship died in this one. They also evade if they have multiple enemy targets. So, if I scroll back to here, its seek went to the health pack more than evading the 2 targets, but it does have an evade that works when there's 2 targets within the range. It's seen more in this one, in the finite state machine. This one won't be able to do both behaviours at the same time. However, it will show the players walking towards each other in the radar. So as this player starts to come towards this ship, this one, as it goes into the attack range, will start to turn towards it. Both players will communicate, and then as that one dies, it starts to wander away, and then this one becomes a target, so it moves in towards it. This one starts to evade as it's on lower health, and the other one came in with the extra radar, and now goes to the health pickup. These behaviours are mimicked in the fuzzy, but you just have them working at the same time.